Hello everyone. Today we are going to learn about chemical vapor deposition or simply CVD. CVD is a very important technique used in nanoscience and nanotechnology. Many things we use today like mobile phones, computer chips, solar panels and sensors are made by using this kind of process. In this lecture we will understand what CVD is, how it works step by step and where it is used. Don't worry, this will explained in a simple and clear way. Let us first understand what CVD means. Chemical vapor deposition is a process where materials are formed as thin layers on a surface using chemical reaction. In this process, chemicals are first converted into vapor or gas form. These vapors react on a heated surface and a solid material is formed. Because this happens atom by atom, CVD is very useful in nanoscience where we work with extremely small dimension. CVD is important for four main reasons. First, it gives very high control over material thickness even at nanometer level. Second, it creates uniform coating, that meaning the layer is evenly formed everywhere. Third, it can be used to make many types of material such as semiconductors, metals, oxides, and carbon materials. Finally, CVD can be used in both laboratories and industries, making it suitable for large-scale production. Now, let us see how the CVD process works. The CVD process happens in four main steps: introducing chemical vapors, moving them to the surface, chemical reaction on the surface, removing unwanted gases. We will now understand each step one by one. Step 1: Precursor introduction. In the first step, special chemicals called precursors are introduced into the chamber. The precursor is a chemical that contains the material we want to deposit. These precursors are converted into vapor form. A carrier gas such as hydrogen, nitrogen, or argon helps carry the vapor into the chamber. By controlling the gas flow, we can control the thickness of the material layer becomes. Step 2: Transport to the substrate. Once the vapor enters the chamber, it moves towards the heated surface, which is called the substrate. The gases slowly reach the surface and spread evenly across it. This step is very important because uniform movement of gases results in uniform coating on the substrate. Step 3: Chemical reaction on the surface. When the vapor reaches the hot substrate, chemical reaction occur. Due to heat, the precursor molecules break down and form a solid material on the surface. At the same time, unwanted atoms forms gaseous byproducts. The temperature of the substrate decides how fast, how well the film is formed. Step 4: Removal byproducts. In every chemical reaction, some unwanted gases are produced. These gases must be removed from the chamber to avoid contamination. This is done using vacuum pumps and exhaust system. Continuous removal of byproduct helps in getting pure and high quality of thin films. Now, let us understand how the thin film grows. Atoms from the vapor stick to the surface and slowly arrange themselves layer by layer. A thin film is formed. Depending on the condition, the film can be smooth, rough, crystalline, and amorphous. The thickness can range from a few nanometers to several micrometers. CVD depends strongly on a few important conditions. One is temperature, pressure, gas flow rate, time. Temperature controls how fast the reaction happens. Pressure affects how gases move inside the chamber. Gas flow rate controls film uniformity. Time controls how thick the film becomes. Careful control of these conditions is a key to success. CVD. Materials made using CVD. CVD is used to make many useful materials. Semiconductors like silicon compounds are used in electronics. Carbon materials like graphene and carbon nanotubes are used in nano devices. Metal compounds are used as protective coating. New two-dimensional materials are used in advanced electronics and sensors. Substrate used in CVD. The surface on which deposition occurs is called substrate. Silicon wafers are most commonly used substrate. Sapphire is used for LED materials. Metal foils are used for growing graphene. Glass and quartz are used for optical application. Choosing the right substrate is very important for good film quality. Application transforming technology. CVD is used in many real-world applications. It is used in computer chips and microprocessor. It is used in solar cells for energy generation. It is used to make hard coating and on cutting tools. It is also widely used in nanomaterial research. In sum, in summary, chemical vapor deposition is a simple but powerful technique used in nanoscience. It helps us create very thin and uniform material layers. The process involves gas interaction, surface reaction, and film growth. CVD plays an important role in modern technology and research. Thank you.